Good evening, everyone. Really happy to be here tonight for this grand finale. So lots of pressure because we're the last thing that stands between us and the final cocktail and event closing this magnificent Adopt AI session at the Grand Palais. So we're going to talk about digital twins today as part of the Powered by AI conference series. It's a conference series organized by the MIT Club and ENGIE since a couple of years now at the intersection of AI and the energy transition. So we're really happy to have an amazing panel to talk about digital twins from various perspectives. We have David, who will ground this in real industrial operations at ENGIE. Nadia, who will bring the systems level decision-making, decision twin from the startup area. Juan Pablo on the hybrid and physical AI shift. And Pascal, who will connect this to current research. So thank you for being here, and I'm looking forward to the discussion. So to get things started, we will start by trying to set up the stage for what it means to talk about digital twins. The word has been around for decades. It has evolved with AI combining with traditional approaches. So maybe, David, if you want to start in terms of the use cases and how do you perceive digital twins in industrial operations?
Yes, and also maybe what is the definition of a digital twin, because there are plenty of them. So in ENGIE we call that a digital twin, and digital twin is not just images from our physical assets into the digital world, but also to plug all the information we have on IT, OT, the different ERP we've got, and also the plan ID cards. So everything we had in terms of information is related to the digital twin. So it's the same amount of information we have in the real world into a digital assets.
Okay, I will intervene in the same direction. So during a lot of time, we think about digital twins or just a digital image of a product or process, or just a process that we are monitoring and getting data and try to understand what it behaves. And now, today, the trend and what we see is that we can connect both and build this dialogue between this digital replica, this digital based on physics, with the real asset. And we use AI to bring the complexity of this digital replica, this simulation based on physics, into the real time and don't make them dialogue with the real asset. And this is the trend today and what we see that it's working a lot.
So very often we talk about digital twins as a replica of physical assets, but sometimes it can be a process, it can be a system that's not physical, right? So maybe you have...
Yes, definitively. So at Cosmo Tech, we have a different vision and a different definition of a digital twin, which is definitively complementary. So in fact, we are putting the asset and the physical, I would say, the physical asset into their context of operation. So it's not only the asset that we will model and simulate, it's also how it will be used and how it will be maintained over time, how it can be renewed. So that means that we will represent the group of assets, a network, all the processes, the people, the objective of a company, and that's a decision supporting tool, meaning that you can see how this overall system will evolve over time. It can, we can look at various time horizon. It can be very short term or very long-term horizon, so among 40 years, for example, to project the CapEx and the OpEx trajectory and find best trade-off. So that's really a system-level type of twin to find a global optima and make sure that you best address a variety of constraints and a variety of objectives.
Yeah, I think what you're saying about global optima is incredibly important in the sense that a lot of efforts now around AI in industry are optimizing locally some parts of the process through use cases. But I think if we want to model the whole end-to-end process and system, we need to think digital twin is a good way to do that, right?
Yes, for sure. And if I had to give you two benefits of this system view level, I might take two examples. So this logic can be applied to a to a variety of decisioning area, but I will continue first within the space of energy and utilities and looking at potentially asset management strategies. So if I'm taking two examples, there is one which is which relates to an hydroelectricity provider on the run, and so here they are using this type of approach to represent definitively constraints that not only relate to those maintenance operation, but also to the need to produce electricity, to the need to produce it at the right time, because the energy price is not always the same. So it can be opportunity based, and you need to ensure a variety of commitments that relate to navigability of a river, or to let's say some other commitments, safety areas and others. So we have a capability to capture all those elements, and at the end to best position the maintenance operation or the renewal operation, so we can delay some at the end. Throughout this prioritization, you will anticipate some operation, you will delay some others. As a result, you have a plan which is really feasible and that really address the corporate objective. So if I take a second example, that might be a Swiss distributor of electricity. And so in this context, we are speaking about energy transition, so they have huge reinforcement needs, and they want over the next 20 years, they want to best plan those reinforcement operation nearby, then the maintenance and the renewal of the current grid assets, so meaning of the current network. So they have a plan already. Before using a tool, they have a plan, and they have a CapEx trajectory. They have also an estimation on how many human resources will be needed for that, what will be the projection in terms of asset value, financial value of the network. And throughout the usage of a tool that will make this system-wide approach really possible, they are able to reduce significantly by 30% the CapEx trajectory, by 30% also the extraordinary depreciation of the assets, and by 15% the need of human resources. So that's the value of system-wide approaches.
Okay, thank you. And from the research perspective, what do you think are the building blocks, or how do you define digital twins and hybrid digital twins?
Yeah, so I fully agree with what Nadia said about the opportunity to combine physics-based models and data-based models. We, as an enterprise organization, and we see this not also in public organization, looking at how we can adapt to climate changes, like the European Agency for Space Studies. So natural system can be modeled by digital twins, and combining this model, so the physics, so can be energy, mechanical, thermodynamics models combined with that you built, for example, early enough in the process to understand the phenomenon or to understand the assets, combined with the data that are collected via IoT sensors, is a, I will say, win-win approach, because the model-based approach is inductive, means that you can interpret very easily what is happening. And on the other side, the data-based models are cost-effective, can be rapid to obtain via AI, but they are more difficult to interpret, and also it's difficult to extrapolate with this. So combining both can be very fruitful. And that's the core of the studies that we are, our teams. So at Inria, we have, I will say, 2/3 of our teams, means more than 180 teams working with AI. These aspects that, for example, physics-inspired neural networks are very important topics to study, because it will help both domains, so the modeling and the data analysis to converge on solutions that are more precise, that avoid, I would say, hallucinations, because you have the physical constraints.
So David, when we were talking, you were mentioning that you consider digital twins as sort of a Google Maps for operation and maintenance. Could you elaborate a bit on that?
Yeah, yes, indeed. I'd like to talk about Google Maps because everyone is a user of this kind of solution. And digital twin is kind of a hub for our technical operators in the field, but also for their managers and also for different people in the offices. So when you launch the digital twin on your computer or on your tablet, this is like a hub. And what is key and what I call that Google Maps is because at the beginning, Google Maps, it was just used to find the way to go to point A to point B. And now in Google Maps, we can find restaurants, whatever we ask. We've got plenty of information. And this is the key for the transformation journey with the digital twin. The amount of information you plug into it. Because if not, it's just a virtual replica with anything else than images. But when you have those kind of information from the ERP, from your old documentation, from all the IoT scope, it's very powerful. And for people from the field, they can, after that, address plenty of use cases, very different use cases. The same we've done in Google Maps at the end in the real life.
So if I look at the various definitions that you bring to the table, I think there's one that's around representation. How do we model the systems in place, whether they're physical systems or processes? One that's around simulation and what-if decisions, either real-time decision scenarios in controlling equipment or processes, and longer-term strategic decisions on where do the investments go, CapEx, OpEx, balance, those kind of things. And then there's the control and command approach, which is, can we between machines and human-in-the-loop systems, make decisions that are operationally more efficient. So let's switch gears a little bit, talk about the use cases in light of the value and adoption, which seems to be the biggest hurdle that we're facing now. We talk a lot, this conference is called Adopt AI. We have a lot of models, algorithms exist, the technology is there. One of the issues is data. Do we have the right data? But at the end of the chain is how do we think about transformation? And you've been an entrepreneur and researcher. You were an entrepreneur that got acquired by a large company, and you work in industry. You work for a large company as well, and you're an entrepreneur. So you've faced different sides of the spectrum. Would you like maybe to start on how do you consider this aspect of value and adoption?
For the adoption, I think there is a study that says that 90% of the POC done for AI fails. Okay.
It's an MIT study from last year. Yeah.
Exactly. I think the key point here is to choose the correct use case and detect the value. What we see when applying digital twins, not only as a source of information, but also to understand our process, our product, our factory, and perform all these what-if studies, even if we have never seen this kind of behavior, we can simulate or emulate with this digital twin. So what we see, the main value that make this adoption works is, one, the time to market, acceleration. Thanks to digital twin, we understand our process and we can go really, really fast to produce faster and to find faster the optimum in terms of energy consumption, performance, and so on. That is more in the digital twin for design, we can say. If we look at the processes and factories, the digital twin, we can detect a lot of anomalies that are not in our historical database. Because thanks to the digital twin, we run those what-if scenarios. We can train an AI to detect those new scenarios and then At the end, we detect the anomaly, we make corrections, and that we save time, we save money, we save energy, materials, and so on. And this is a super ROI that makes the adoption easier. So the risk, the operational performance, and then for all the people doing and producing, making products, the time to market. This is almost today one of the only way to accelerate even more this development cycle.
So
Nadia, maybe talk about data,
Sure.
stakeholders, silos. Yeah, how do you think about those things?
Yes, sure. So I fully agree with what you said, Juan Pedro. So I think there is a tremendous opportunity in getting new data that will help us to be best, to react the best way when there is an anomaly detection, for example. But I think there is also something, when we do collect this data, obviously, so we do gather data from which we can also learn, and that helps. But it's not enough because definitively, something that can happen that does not happen in the past. And more than this, if we don't have data, which might happen and which is often seen as an entry barrier, then we can have, and especially when you look at processes, so we can have probabilistic approach. And probabilistic approach could also help in combination with, let's say, real data or historical data. So, for example, we don't know how this task duration will really evolve. What will be the lead time to deliver a part? What will be the evolution of a demand, of a tariff, of a cost? So we can apply variability on all those aspects and take a decision that will be informed also by those probabilistic approach. So it will not only be a performance decision, it will be a resilient decision. My point is that regarding the entry barrier that represent data, this is one, and we are getting more. We are better and better on that front, but probably this shouldn't, prevent us to start because you already have a lot of benefits. So the customer are more and more eager to start even when they don't have data. On, let's say, the adoption of a different approach, which might be more holistic. So it's a journey. It's a journey because this is not really our way of thinking and the way we are organized today in our company, probably in our society. So we have a kind of siloed approach and thinking in system, thinking more globally to reach, let's say, those global optimum and to make sure that we are not focusing on local optimum. That requires a change in thinking, that requires a change in organization. So our customer, what they are doing is that they are making sure that everyone is onboarded since the start within this journey, and they are trying step by step to put that, to make this a reality. But that's something to be continued.
So Pascal, what's really interesting in your journey is that you were a researcher, you went into entrepreneurship, you started companies, and then became again a researcher because you identified gaps in the technology stack. Could you elaborate on that?
Yeah, I think that we observe that especially for small enterprises, this journey is long and can be time-consuming and also costly. So I came back to research because I think the goal would be to automate the process, to give tools to help, for example, the hybridization of models and data that were not there when I started my startup in 2020. And that is the reason why we are launching a national initiative on engineering digital twin, focusing on public organization and small enterprises to help them accelerate, I would say, the development cycle and also the adoption cycle of digital twins by providing methodologies, but also an open source platform so they can start small, identify the value they can gain from the adoption of digital twins and the data that they collect, and also to start having this I would say, virtuous cycle of making all the stakeholders collaborate on this data, on these models, on these tools and services that are provided with the digital twin. So our goal is to federate siloed communities that are, I would say, building ad hoc solutions and helping companies that cannot afford, I would say, very integrated and costly platforms.
Interesting. And I think, David, you can illustrate what we're talking about with some of the use cases in terms of rethinking end-to-end processes like operation and maintenance on electric transmission lines or optimizing the production of biogas. How do you apply those models to these kinds of use cases and scopes?
Yes, we've got plenty of use cases. Indeed, one of them could be the simulation of intervention before go on the field to do it in the concrete live. When you started in your digital twin to simulate your intervention, you can address plenty of different simulation, but the first one for us, the most important, is the no life at risk. So we want to reach our yearly goal to have 0 fatalities within the group, and to help the health and safety scope. Simulation are the best way to prepare everyone before an intervention. So you simulate it virtually in the digital twin with the manager and the technical guys before on the digital twin. See what could happen, what could be avoided, and after that deploy it on the field if everything okay. And you mentioned also another use case here. For example, in Brazil and in Chile, we've got power transmission lines for electricity power. And in those 2 countries, we've got very, very long power transmission lines. For example, in Brazil, the longest one is 4,000 kilometers long. So you are in the middle of the Amazonian forest. It's very long, and if you want to go to point A to point B, it's 4,000 kilometers. In Chile, it's different because it's in the middle of deserts, so it's not the same time of geography. But at the end, what we deployed is thanks to catch some images with drones. We analyze them thanks to AI, and it avoids a lot of number of hours for a technical guy to see the different videos of the drone second by second. The analytics we made thanks to AI is huge in terms of performance, because you can analyze 20 hours of a video in just 1 or 2 real hours after that.
Yeah, what's really interesting to me is how broad digital twins can be applied in terms of manufacturing, in terms of processes that are run for producing electricity, transporting energy, in terms of human processes. So it covers a wide variety of things, both physical systems, territories-based modeling as well. What I'd like to ask you about now is the trends, if you will look into the future. And I think we've got the right mix of people, so from research, from technology stack, through applications. How do you see the merging of what we would call hybrid digital twins with agentic AI, for example, and other trends that are coming into the development stack that will pave the way for the future?
So we said about the combining models and data. There is another aspect that is very important. It's the composition of digital twins. So you start with, for example, a piece of the car, and then you assemble a car so a complex system. We have the same with the digital twins, and after you will have a fleet of cars, means that you will have to federate the digital twins of these cars. So we can see at the end that we will have an internet of digital twins over an internet of things, and there are a lot of open research questions about the validation of these I would say, very interrelated systems. Who is taking the decision, etc. Where is the truth of the source of truth? So that's the type of problems that we are addressing in the labs and initiatives that we launch. So all this needs also interoperability of this digital twin. So we have to define the interfaces, the standards to enable this federation of digital twins. Of course, there are many I would say issues in terms of deployments, and for example, we have sustainability issues, also privacy. So a lot of enterprises don't want to share their data. So we can think about the distribution of digital twins, so the data stay close to their source, but we can share, I would say, part of the models, not the key and raw data. So that's a federated learning applied to digital twins. So there are many ways to adapt to the constraints that we have, and we see that it's coming, and we see the convergence of different approaches that will bring more trust, because the trust is an important aspect, because you have a tool for making decisions, and a lot of people not necessarily trust in the models, not necessarily trust in the answers the system is giving, and if you want to act on the physical world and save or be sure that nobody is in danger, so we are working also on model validation, formal validation, as well as empirical validation, to keep the human in the loop and make sure that everybody agrees and adopt the technology.
Okay, one thing, I confirm the data sharing is a hard point and really, really important. In Siemens, we are developing an industrial foundational model, and we need a lot of data, and we need the other industrial partners to share the data to build this model. Coming back to the agentic AI, again, we have this vision about design and operations. For design, we see the agents helping to build the digital twins, because it's a sort of intelligent automation. So we can ask the agent, create all the models that we need, perform all the simulations that we need, the design of experiments, and then perform all the operations to get, at the end, this almost real-time product digital twin. Now that is okay, and we already did something like this. In the operation side, it may be a little bit dangerous if we let the agent to be autonomous and make decisions in critical systems. Because anyway, an agent is based on language models, and we know that they can hallucinate, even if we work a lot to try to avoid this. And let them to make decisions in those kind of systems can be dangerous. But we can let them to organize, collect the data, perform some operations on the data, and then bring a sort of summary, the most important part of the data, to the human in the loop, and let the human make decisions. So it's more support of the decision that a fully autonomous agent in terms of operations.
So yes, I agree that the combination of the different techniques is quite promising actually, and may also generate risk. So I think when we talk about Gen AI, so LLM, adjoints, so this is a promise of simplification probably that helps in adoption. So it's a simplification in our way to navigate, for example, within those various tools, within the result of our scenarios. So it should help for adoption. We see this promise already becoming a reality. So that's one part, but on the other end, this acceleration in decision making and in the execution of a decision, if we do accelerate, let's make sure that what we accelerate are the best decision. Otherwise, we are generating a higher risk of actually, bad performances. So I think the combination, from my perspective, the combination of those last trend of AI plus simulation and plus other techniques probably can definitively make sure that we are all together, looking after two opportunities. The first one is on each market make a differentiating advantage because we are looking for those global optima, as I was describing. And second, for our planet, that we are taking faster, better decisions that serve not only the financial purposes, but also other purposes, such as the environmental impact. So.
Yes, and on the AI part, indeed, if you want to unlock the full potential of a digital twin, we have to put AI above that. And this is our point today here in ENGIE, because we deployed a digital twin for more than 4 years now. And what we saw is we didn't unlock the full potential of the digital twin. And as you said, it's very important to, if you want to accelerate, to put in place some kind of AI to unlock and access to all the information we have. And it's impossible to have access to all the information you have in the digital twin in real time. And after that, it's a good question. You mentioned to make the right decision, because with a large amount of information, it could be tricky to take the right decision at the right time. But after that, to have at least many scenarios in front of you and decide something, it's possible.
So I'm hearing that we use digital twins to model systems of systems, which is becoming increasingly important in a complex world, to describe also the physical world, and having replicas that help us make decisions. So just a final word, one sentence, if you were to give an advice to a team starting on digital twins now, what would it be?
So I advise, do not be shy, try, so learn, because you will fail, but you will learn a lot. So starting small with easy, and then plan and think about the real benefits you want to get, or the real problems you have to solve, and also be confident that you already have a lot of components that will be integrated in the digital twin, and leverage these components.
One sentence. Don't be shy. If you can use real data, simulation, combine them with AI, and build a digital twin, because it will work.
So I guess, yes, value-based prioritization, value-based approach, start small, but start as soon as possible. And yes, I think it's a very interesting journey, a very passionate journey, so a lot will come.
Yes, start as soon as possible, because it's a legacy for the future. And when I said a legacy for the future, for the 40, 50, 60 years to come, they will have an asset, a digital replica of what they had in the past. It's very important to have this.
So we have a lot to say, but we're going to end here. Thank you very much to the amazing panel. Just a quick word that previous replays of Powered by AI are available online, so come to us to check it out. And we have a next session of Powered by AI next week on Tuesday, 2nd of December, on AI and people. So thank you very much for the very interesting conversation.
Thanks.